So hi guys. So in this video we are going to deal with invaders movement. So far what we have right now is we already have all the invaders instantiated on the screen, and now we are going to deal with making them move throughout the screen. The invaders movement basically consists in they all start moving to the right, and each time they reach at the edge of the screen, either on the right or on the left, they invert direction. So they are start moving right, they reach the right edge, and they are going to invert and start moving left. They reach the left edge, and they invert again. And also, each time they touch the edge, they also shift downward a little bit. At the time, I think it was like an entire row, but from what I tried, an entire row is really a lot. So we are going to do like maybe a middle height of a row. You know, like a row has like 28, let's say, between rows. So you're going to probably do something around like 14 units, something like that. And just to fix some problems that we had on the previous videos. So first, the invaders were not centered. When we were doing the video about instantiating all the invaders, they end up not being centered on screen. And yes, and that was because I did some mistake with the math. Because when I was calculating the position of the first invader, I forgot. I said that sorry, not this. But when I was doing this, I said, okay, we are at 90 units. We are at when I say units, it's pixels, but I'm gonna call it units. The first invader is at 90 units from the left edge. And so if the left edge is at minus 240, minus 90 plus 90 in this case, is going to be minus 150. But what I forgot is that the position of the invader is in the middle of the sprite and not on the edge. So it would be minus 150 if the position of the invader was right here on this edge. But since it's in the middle, we need to add plus 10. So the first invader will not start at minus 150, but at minus 140. And I already changed that here. So we need to change on the original sprite is not that necessary, but we can see that original sprite. Now we cannot see it, but now we can see it that it's on the correct place. But basically, you need to change it here. So go to x minus 140. So the first invader will start on the correct position, and now when we instantiate all the invaders, we can see that the middle column of the invaders is aligned with the player, and now it's correct. Now, this was the first thing. Another thing that we need also to do is to hide the first invader, so the original one, because if we forget to hide the invader, it's going to be visible here, despite we are going to instantiate another invader on top, but you can see that the animation doesn't seem to be working because the original invader is not playing the animation. So let's just make sure that the first invader is also hidden when we start the program. So we click, and when we click the green flag, we hide the original invader. So in this way, I'm going to hide it here, but it's also always correct. So now we have the animation correct, working correctly. And another problem that we had, and I think I talked about it on the last video, was that when we were destroying the invader, sometimes the player laser would just go through the invaders. I mean, would be destroying the invaders, but then would just continue moving up and not destroying itself because it was not detecting the collision with the invader that it just destroyed. And I was in part correct about why that happened, and it was basically, my idea was that basically it was because the explosion sprite that I'm using doesn't have anything painted in the middle. And so what is happening is that when the laser hits with the invader, we change the invader costume to this one. And since we changed the invader costume to this one, then the laser is able to pass on this corridor right here without touching any other pixels that are painted. And the collisions in Scratch are between the painted pixels and not the sprite itself. So that was what was happening. So I tried to solve this by just adding a few pixels like this. So in theory, what I thought was like, okay, so now if I don't have like this corridor of empty pixels, what would happen is that the laser would eventually all hit one of them and would detect a collision and destroy itself. And it worked partially. So I can show you. Yeah, I need to change the costume because I think I have the old costume, and just to show you what's happening right now. And here we can see exactly that problem, because right now we are sure that since the player is aligned with the middle column of the invaders, so we know that when we shoot, the laser is going to be exactly in the middle in that corridor of empty pixels. So right now, if I shoot, you can see that it just goes straight through all the invaders, because that's exactly what's happening. So if we change the sprite to the new one, and I'm going to import, we don't have a way to just replace the sprite, so we need to remove the sprite that we have and import the new one. And I have this is the new one. We can see it, but it is the new one. And the code, let me see. Yeah, I had the old because I was using the old. We have invader explosion. Also make sure, and this might happen because if you are going to replace a sprite by another one, please make sure that the sprite has the same name as the previous one, because the name that you were using is going to be here. And if you don't change it here, then it won't work, and you might not understand why. A way to do it is just coming here to the sprite and changing the name here to be the same as the last one, or changing the file name, because this will adopt the file name when you import the sprite. And now we can try with this new sprite, which is the one that I just showed you guys here. And let's try it, and it works on the first one. So you can see, okay, it's working, but then it doesn't work on the other one. And it works not on the first one, but it destroys on the second one. And this happens like on the second and the third row, and on the fourth and the fifth. And I was like, okay, I'm not exactly sure why that happens. My theory about this is that might probably be related with the animation of these sprites, because even these sprites, the ones from the invaders, these ones that are running the animation, let me see if I can show you guys here. Import, no, it's not import, it's here, import, yeah. Okay, browse physical files, let me open invader 1, replace, no, yeah, replace, yeah, okay, no problem. Okay, so you see, the onion skin, so you see that the laser is probably detecting the collision here, or here. It should be here in theory, or when if the laser gets to this sprite when the animation is on this frame, it would detect a collision here on this pixel. But maybe when it detects on these ones that are also near the middle of the sprite, it does not detect the other pixels that we have on the explosion. It might be related to this. I'm not going to waste too much time on this. We have another way to solve it. So another way to solve it is that, so this is about waiting before changing the sprite. And why does it happen? Because the problem right now is that since when the laser touches the sprite, in this case the sprite touches the laser, we change the costume immediately, that sometimes might not give the laser time enough to understand that the collision happened. Because if we change the costume immediately, then the laser might be trying to detect a collision with the explosion sprite and not with the invader sprite. And so that's why it doesn't is able to detect. So one way that we have to do that we can do it is to add a wait seconds just before switching the costume, and a really small wait second. So we are going to add a wait second to 0.01. This is for us, we can see it, so it's exactly the same. But this, since which we wait, so the hit happens, the collision happens, but we don't change the costume. And this gives enough time for the laser to detect the collision on its side, and then we change the costume and do everything else. And this, I think it solves our problem. So we have this, which works on the first one, works on the second one, the third one. So I think this solves the problem. And to show that this is probably working correctly right now, we can even change the costume back to the other one. So I had the old one. I'm going to go back to the original one, the one that didn't have like all these, the other sprite, the other pixels that I painted. So the one that had like the row in the middle without any pixels. Yes, I'm gonna explosion. Why did it call explosion? Okay, I'm gonna call it invader explosion, so it has the same name. And probably I'm on the sorry, I was on the original project that I worked in. So here, I'm gonna take this alt, so it stays with the same name. And now this was the sprite that when we were using and shooting from exactly the middle, it would just go straight up and destroying everything in this path. And now it's working perfectly. So this little wait seconds is a way to solve this. So when we have two different sprites trying to detect collisions with each other, between each other, sometimes we might have to do something like this. Okay, one of the sprites is going to have to wait before changing something that would prevent the other one for detecting that collision. So this solves our problem. And now we can start dealing with the movement. So, like I said before, when the invaders start, when the game starts, the invaders start moving to the right. So, to move something, to move a sprite to the right, we already know that we need to change x by something. And if we are moving to the right, so the x value needs to be positive because of the coordinate system. And so let's change by 1, and then we are going to be doing this forever. So we need a forever block. I mean, we need a forever block, yeah. We need a forever block, and this is the way that we are going to change the sprite. So it's going to be running forever, and on each frame it's going to change the x of the sprite by 1. And then we can connect, for now, let's just connect this forever block here. Because it's related to the position, here we are dealing with the sprite position, so we can just put all together in this moment. And then we're going to need to change it, but at this moment it makes sense. And I'm saying this because I usually like to separate my blocks into the functionality that they are dealing with. So right here I have when I started the clone, the forever blocks, when I have when I started the clone, and all this is about the costumes, just doing the costume animation. This, for example, is just for doing the collision with the laser and destroying the invader, and this one is about the position. This might not, I prefer to have this approach, to have all these blocks separated, and because I could just put this here and use this forever to do all this change x. But it might get difficult because you need to worry about if you have wait seconds or not, or something like that. But on the other hand, the disadvantage of having all this separated is that if you are changing something in one of these forever blocks that might impact the other ones, you need to be aware of that and go to the other block and change it as well. But I prefer it this way. And I just remember that we need to also change something here, which came from the last video that I forgot, which since we are using clones, we won't be hiding the sprite anymore, but we are going to be actually destroying the clone. And okay, just change what we had in this block, just change the height to delete this clone. And okay, coming back to the position. So when we start as a clone, we position the sprite in the correct position, we show the sprite, and then we start a forever block that will change the sprite x by a certain amount. Let's do it 1 by now, and let's try it. And so, yeah, the sprites start moving to the right when they reach the edge, and at this moment just stay there. You can see that we have a little offset between the rows. This is because since all the sprites are being instantiated one after the other, some sprites will start moving before the other ones. So the last ones to be instantiated will start moving after, and then that's why we have this offset between the rows, but we'll fix that in a moment. Right now, let's just focus on the movement itself. So they start moving, and what we want is that when one invader reaches the edge, being the right edge or the left edge, it just inverts the speed, the movement in this case, not the speed. And so first we need a way to detect that the invader is touching the edge, and we already know how to do that. We know how to detect collisions, which is with the sensing block, the touching block from the sensing category. So we have this one, and we can change to touch the edge, and this works perfectly for all the edges. So it's not about just one of the edges, but if the sprite touches the top edge, the bottom, the left, or the right, this works. Which in the other cases, if you want to say that if the sprite is touching a specific edge, like the right edge or the left or the top or the bottom, you need to combine this touching edge with also the position of the sprite. So you know that if it's touching the edge and the x position is greater than 0, then it's touching the right edge. Yeah, but then you need to also consider the y position. But that's not a problem for what we are doing right here. And let me just see. Okay, so we have touching the edge. Now we need an if condition. So if touching the edge something happens, we already know how to do it. And we can add this here. So inside the forever block, so we are moving the sprite and constantly checking if the sprite is touching the edge or not. And now we need to invert the direction. And to invert the direction, basically, we need to hold the value that moves the sprite. So for the sprite to be moving to the right, we are going to be changing x by 1. When we want the sprite to start moving to the left, we need to change x by -1. So we need to have a variable that we can change the value each time the sprite touches the edge. So let's create a new variable. And in this case, we are going to be creating a variable only for this sprite, because we don't need to access this variable for anywhere else. Only the invaders are going to be dealing with their own speed. And let's call it invader speed. I would be tempted here to just call it speed, and because I would think, okay, this variable is just for this sprite, and I know that this variable belongs to the invader, so if I call it speed, it's the invader speed. But I have the idea, I didn't verify this before, but I have the idea that the variable names must be unique throughout the whole program. So even if this variable is only for this sprite, we cannot have another variable with the same name, and we are going to need to create some other variables called speed. And so let's call it invader speed. So we know, okay, this is a variable for the speed of the invaders. And don't forget to put for this sprite only. Yeah, already exists because I created it earlier when I was testing this. So I already have the invader speed variable. Yeah, but you can create one. And now we have the invader speed. Instead of using change x by 1, we are going to change x by invader speed. And we need to make sure that before starting to move the player and using the invader speed, we need to make sure that the invader speed has a value of 1. Because all variables start with the value of 0. So when the invader starts as a clone, we set invader speed to 1, and then we are going to be moving the invader by the value of the invader speed, which is 1. When the invader touches the edge, we need to invert the value of the invader speed. And to invert the value of the invader speed, first we need to set the value of the invader speed, and to invert it, basically what we need to do is multiply the invader speed by -1. And this inverts the value, the value. So if the value is 1, it becomes -1. If the value is -1, it becomes 1. And so now we can try it. Let me see. Okay, so when the invaders reach the edge of the screen, they start moving the other way. And that will also happen when they reach the left edge. Let's just confirm that, but I'm pretty sure that it will happen. And yes, this is what we want. Not exactly, but we are in the correct path. And so the invaders are moving, they start to the right. When they touch the edge, they invert the direction. What we need to change now is that the invaders are inverting the direction, but only when each one of them touches the edge. And that's not what we want. What we want is that when the first invader touches the edge, it tells everyone else, okay, all of us need to invert direction and start moving the other way around. So we need to change this to make it to work like that. So it's not when the invader touches the edge, but it is when the first invader of the whole group touches the edge. It tells everyone else, okay, everyone invert the speed. And this brings us to the first time where we need to communicate between sprites, because what we have right here is that one clone of the invaders is going to have to tell everyone else that they need to do something. So basically the sprites who are going to be the clones in this case are going to be communicating with each other. And the way that Scratch has to communicate between sprites is using messages. And we have this block, so we have the block when I receive a message, and we have the block broadcast message. It's called broadcast because basically the message is sent to the entire program. So this is important to think about, because we cannot send a message between sprites. So one sprite cannot say, I want to send a message to that sprite, which would be awesome and really useful, but we cannot do it here. So I talk about this about the laser, because the laser was able to detect the collision with the invader, but it is not able to detect, I want to send a message to that specific invader. So what we can do with messages is that a sprite can send a message to the game, any message to the entire game, and the sprites that want to receive that message to do something about it need to have this block. When I receive that message, I'm going to do something. In this way, in this problem that we are trying to solve is exactly what we need. So an invader is going to send a message to the program saying, okay, everyone needs to invert the direction. And all the invaders are going to be receiving that message and say, when I receive that message, I'm going to invert the direction. So what's going to happen is that instead of inverting the direction when the invader touches the edge, we are going to invert direction when they receive the message. And when one of the invaders touches the edge, it's going to broadcast that message. And now message 1 is the default one, so we are going to create a message more descriptive. So let's say it invert direction. So when the invader touches the edge, it broadcasts the message invert direction, and when any invader receives the message invert direction, it inverts the speed. And so now, when one of the invaders touches the edge, sends his message, and everyone just inverts the speed value. And if we try now, we have this invader will be the first one touching the edge, and it worked, and this one as well. And now it's working. So what we are missing right now is that also when the invaders touch the edge, so they invert the direction, but they also shift downwards, because one of the losing conditions is where the invaders are able to invade the Earth. So when the invaders reach the line of the player, or below the bunkers that we'll have in the future, when they reach that level, the game ends, or the player was alive. So besides, when they receive invert direction, besides inverting the direction, we are also going to need to shift the position of the invaders on the Y position. So we are going to use the motion. On the motion category, instead of changing X, we're going to change Y. And like I said, we are not going to change an entire row. We already know that invaders are 28 units apart from each other, because they are 20, they have like 8 units apart from each other. So each row, even on rows. So if we wanted to change a whole row, it would be 28 units. We're going to do half of it, so it's 14. So we're going to change it Why? By minus 14, because they are going to be moving down. So each time they reach the edge, they invert the speed and they shift down one row or half a row in this case. So I just see, and yes, it's working. Okay. And now the last thing that we need to do is to fix this offset between the invaders. Like I said, this is happening because the invaders start moving before all of them are on screen. So what we need to do is that we are starting the movement part, not the position, but the movement part. We can only say the invaders, okay, start moving when all of them are already on screen and created. So in this case, we are going to need to be using messages as well, because we're going to need to tell everyone, okay, now you can start moving. And we know that all the invaders are created when we reach the end of this block. So when this repeat 5 ends is when all the invaders are already on screen. So that's where we are going to broadcast a message. And let's create a new message. I'm going to call it start. Just start, like, okay, this is a message to start the game. So we are going to wait for all the invaders to be ready, and then we're going to say not only the invaders, because we are going to use this message to other things, but we are going to say everyone, okay, just start. And we broadcast start, and in this case, I'm going to put this here, because this is about messages. And in this case, when the invaders receive the message start, they are going to start moving. And in this case, the message, who's broadcasting the message is the original sprite, who's broadcasting the message to all the clones. Basically, it's that. And okay, let's see. Okay, so all the invaders were instantiated, and when they are all instantiated, they start moving. Now, the last thing that we need to do is to fix the player, because right now, while the invaders are being instantiated, we are able to move and shoot from the player position. So the invaders are being created, and we are already able to start playing, and we don't want that. So what we are going to do as well is the player is not going to, we are not going to allow the player to move or to shoot before all the invaders are created. So we are going to take this from the green flag. So we cannot start the forever block when the game starts, but we are going to start all the player actions when the player receives the message start. So in this case, the invaders are broadcasting the message, all of them are catching the message, and also the player is catching the message to start the game. So right now, we cannot do anything with the player until the invaders start moving. And that's it. That's what we have about the invaders movement. And on the next video, we are going to deal with invader types. So because so far we have all invaders of the same type, we need to change the costumes and everything to have the rows with the correct invaders, because you can see here on the plan and on the original game, the invaders are different in terms of the rows. And then we're going to also deal with the missiles. So the invaders shoot missiles down to the player, and we're going to implement that as well. So, and that's it. See you guys on the next video. Thanks.